Today we are covering 25 hands-on challenges to handle many DataRaptor design scenarios. This video will help you build a DataRaptor toolkit and get ready to use DataRaptor for extracting, updating, creating, and transforming data from or to other OmniStudio components like FlexCards, OmniScripts, integration procedures, and business rules engine. These exercises will be helpful for people implementing OmniStudio projects and those preparing for the OmniStudio consultant or developer certification. If you need to refresh your DataRaptor knowledge, check out episode 5 to 9 for detailed breakdowns of each DataRaptor type. Let's begin. Here is a quick overview of what we'll be covering today. I'll be going slightly faster on these exercises as I have covered how to design these DataRaptors in detail in previous episodes, but I'll still be highlighting best design practice and key considerations. We'll start by exploring the DataRaptor Turbo Extract. We'll be diving into how to retrieve fields from case records, utilizing operators to fetch and sort them. We'll also be exploring using variables, relationship notation, and handling complex input JSON. Moving on to DataRaptor Extract, we'll delve into similar concepts as Turbo Extract. Additionally, we'll demonstrate using formulas to manipulate data. Transitioning into DataRaptor Load, we'll cover inserting combinations of parent and child records, upserting records, and performing lookup operations. Lastly, in DataRaptor Transform, we'll focus on converting data between different structures, such as from a single item to a list with one item, a list of objects to a multi-select item, etc. So with this, let's dive into the hands-on challenges. In this example, we will be retrieving fields from the case records and the following fields using DataRaptor Turbo Extract. We'll be getting ID, case number, description, priority, reason, status, and subject. Let's now move into Salesforce. Select the OmniStudio app and OmniStudio DataRaptors. To create a new DataRaptor, click on New. For this exercise, we will be using DataRaptor Turbo Extract to retrieve case record details. So for DataRaptor interface name, it's always good to name it in a way that it's obvious to you as a developer to know exactly the type of DataRaptor and the object that you are fetching the details from. So in this case, DR for DataRaptor, TEXT for Turbo Extract, case record details, case is the object that will be turbo extracting from, interface type is Turbo Extract. We'll keep input output as JSON. For description, we'll put something down quickly. Fetch case records. Click on Save. So we'll be focusing on the case object over here. And what we want to do is we basically want to find all the case records and display those fields that was mentioned from the exercise. So to do this, we actually want to use this environment variable called velocity.null. And what we want to do with this is, in order to fetch all the case records, we want to set that with the query to say, hey, we want all the case records with an ID. And the way to do that is we want to go ID, where the ID field is not blank, which is this global environment variable, which just means blank or null. And we want to store this query result in this JSON extract output path, which is essentially a JSON node. And we can name whatever we want for this node, but a good practice is to name something that will help you understand where the query result is from in terms of objects. So we'll go with cases. And notice how I've kept it as lowercase. The reason for that is that this helps us to distinguish between the node and the actual object, which is in uppercase. Now we've done the query bit, and what we need to do next is to select the fields that will be displayed back to us when this DataRaptor turbo extract is executed. So by default, the ID field is here, and we want the case number, description, priority, reason, status, and subject. So with all the fields selected, let's go into preview and go execute. Right, so what I've got is no valid data returned. So this is probably saying something that the query is not correct. So the reason for that is you actually needed a quotation mark for the environment variable. So let's try this again. Now this looks a lot better. So what we've got here is the cases JSON node, which we specified over here in extract output path. And each of these items contains a case record. So in this case, Boolean status with a case number of 1027, and with all the fields that's been specified from this exercise. Also notice in the debug log that there's a query over here that basically says select ID, status, description, priority, case number, subject, reason from case where ID is not equal to null. So this is basically what we have implemented over here. Now moving on to the next exercise. Right, exercise number 2 for turbo extract. So this one is quite similar to the previous one, except that we'll be using more operators. So in this example, we will be using turbo extract to fetch only 3 case records and the following fields, and order the records by case number in descending order. So let's have a look how this can be achieved. Coming back to OmniStudio, the best way to create the second turbo extract DataRaptor is by cloning it, since the two DataRaptors will be quite similar. And what we want to do here is we want to name it as DRTEXT case record details using operators. And the reason why we want to create a new one for each exercise as opposed to modifying the previous one is that we really want to build a toolkit that you guys can refer back to when you are preparing for your certification or doing a project. So if you are facing a challenge or a task that you need to do, you can go back to your demo org and have a look at these examples and to see how to achieve them. So first thing we'll need to do is we'll limit the result to only 3 case records. So to do this, we will go over here, add an operator limit. We'll put this to 3, and we'll quickly review this to see how many results are coming back. So yes, 3 records only, and we can see in the query as well. Next thing we need to do is we need to order the records by case number in descending order. Again, add an operator here, ordered by case number. And we'll go and have a look. So now it's being ordered by case number, and we can see that it's currently ascending. So 1000, 1001, 1002. So what we need to do to make it descending is we put DSC after the case number. Click on preview again. And as you can see now, it's now picking the records from the bottom. So previously we had 1000, 1001, 1002, and now this is going from the bottom back up. So 1049, 1046, and 1045. And you can see the query here as well, ordered by case number, descending, limit 3. So this might be a bit confusing. So what is happening is that if we just remove the limit for now, and we go to preview. So here it's giving me all the case records, and because we've put it to descending, it's the biggest number, the biggest case number appears first, and that goes all the way to the smallest case number. So what we are doing when we go descending limit 3 is that it's picking these 3, and when we are going just by ascending, what it's doing is that it's picking the top 3 from the smaller end. So that's why when you put a filter on the limit, and when you adjust sorting by ascending or descending manner, you'll see the numbers being different. Alright, in this example, we will be using variable to fetch case records and relationship notation as a filter on associated account record. So we'll be using DataRaptor Turbo Extract to fetch case records and returning the details on these records, where the industry field on the account object is determined by a variable named account industry, and we'll be adding key value pair as the input parameter to test the DataRaptor. So this DataRaptor Turbo Extract is different from the previous two in the sense that we will be making reference to the account object, which is a parent object on the case record. So remember that DataRaptor Turbo Extract can fetch details from parent records, but it can't do child records. For child records, you need to use DataRaptor Extract. So just a quick recap on relationship notation. So DataRaptor Turbo Extract supports relationship notation. So what this is that it allows you to use fields in related objects in filters, such as parent.name. So in this case, the DataRaptor will be based on case. So to have a filter that's based on the account object and the industry field on the account object, what we can do is in the filter, we can actually use relationship notation, for example, account.industry. So this is quite an important concept, and you'll certainly come across this when you are doing projects or even in the certification exam. So if you are not familiar with this, I will suggest you to check out my video on DataRaptor Turbo Extract. I went into details about how this works. Alright, so what we need to do is to understand this better is that we need to find a case records, and we need to find the related account object and the industry field, because that's essentially what this query will be doing. So I found a case record over here. Here is the account name. When we navigate to this, here is the industry field that we are looking for. So this industry field will be used as a filtering condition for our DataRaptor Turbo Extract. Let's now create a new DataRaptor Turbo Extract. DRTEXT contact details using relationship notation. Interface type Turbo Extract using relationship notation as a filter to fetch case records. Save. So we'll still be focusing on case. We'll keep the output path the same, so cases. For filter, this is where the relationship notation comes in. We want to use account.industry as a filter, and for now we'll give it an actual value, so energy. The exercise here actually asks us to use a variable, but we'll use a fixed value first, and we'll change it to a variable later on. So that helps with the understanding of how this works. So we want to fetch ID, case number, industry. ID is already there. Case number and industry. You won't be able to find it here because industry actually belongs to the account. So what you need to do is you need to select the related object, which is case.account, and in here the industry field will appear. So now if we execute this, we'll now get a list of case records where the associated account object has energy down as the industry field, and it's returned 14 results. And if we look at the query over here, select ID account.industry, case number from case where account.industry equals to energy. So how do we actually make this a bit more dynamic? By using a variable. What we need to do is, let's go back here, and these static values will need to have quotation mark around it, but with variables you don't need it. So what we'll do is we'll put in the variable name, which is account industry, And over here in the preview, we need to add a key value pair. So account industry is our variable, and we'll change this to energy. So this should give us the same result. And you'll notice that the query still stays the same because the only thing we've done is to replace a static value with a variable. So to prove that this actually works, we'll change it to a different industry value. Let's have a look at what else is out there. So banking is there. I'll just change it to something else. We'll go with chemicals. And if we change this to chemicals, nothing actually shows up. And the reason for that is because this account here there's actually no case that's associated with this account. So what we want to do is we'll quickly create a case, and we'll make this cloud with Ryan. We'll save this, and now we've got an account created, a case created with the account associated where the industry is chemicals. Now we should at least get one record, and there it is. So when you are testing your DataRaptors, if you don't get anything back, it's good to go back to your Salesforce records and making sure you've got records that meet these the criteria that's been set out over here. Moving on to the next exercise. This exercise is quite similar to the previous one, where we'll be using relationship notation as a filter. But this one over here will need to be fetching fields from two parent objects. One is account, one is contact. So we'll be using turbo extract to fetch case records and the following fields, where the industry field on account object is electronics. So we'll be fetching ID, case number. These will be coming from the case record, account number from the account object, industry from account object, and name from contact object. So since this DataRaptor turbo extract will be quite similar from the previous exercise, we'll clone this to make it a bit faster. Contact, account, and contact details using relationship notation. Case, account, contact details using relationship notation. Yeah, I just realized that I probably didn't name this quite as well as I would like. It probably is better to name it DRTEXT case details using relationship notation. So I'll do it here. And I'll just put account contact in the end, which is quite long. Okay, I think I've reached the maximum length. So I'll clone this again. I'll just make it a bit shorter. DRTEXT case, account, contact details using relationship notation. Hopefully this is not going over the limit. Okay, it's gone over the limit. Case, account, contact details. Okay, that's better. Right, so what we need to do here is that we need to first adjust this to electronics. So keep the variable here, and we'll just change this to electronics. And what we need to do next is we need to get the ID case number, which we have already got, account number. So again, if we go account number, we won't be able to find it here. We need to find it from the related object. And what we also need is the name from contact object. So we'll need to find go back to case case dot contact, and we need to find the contact name, which is this. Let's go and execute. So it's returned quite a few records. In total, there are 11 records that met this criteria. So let's check if this is what we want. You'll notice that in the response, each of these each of these items are a bit bigger. So it's got quite a few other fields that we haven't specified over here. And the reason for that is because we are using relationship notation. So you'll display additional records such as the contact ID, the account ID, and the ID of the account, and the field that we've specified over here inside the respective object node. So in this case, contact, you'll contain the name node. In the account, you'll contain the industry node. So what this has returned is that it's returned us the case records that's met this criteria, where the industry is electronics, as we can see over here, and it's returned the contact details as well. So having a look at query, select ID account.industry, account.account number, case number, contact.name from case where account industry in electronics. Moving on to the next exercise. In this exercise, we'll be working with complex input JSON. So we'll need to modify the DataRaptor from the previous challenge to take the following input JSON. So starting with open and close curly brackets, and we've got a top JSON node accounts. Inside accounts, we have another JSON node called sections. Inside sections, we have a key and value pair, industry, where the value is banking. So this is quite a common scenario where you have JSON coming from a FlexCard or OmniScript, and this will be using as a condition, as a payload into your DataRaptor turbo extract, and you need to use this information as a filter to be able to extract the information that meets this filtering criteria. So what we'll do over here is we'll clone this. We'll just name this case details complex input JSON. Click on save. Right, so what we need to do here is that let's go into preview. We'll need to edit this as JSON, and a good practice is to actually type this out. So starting with the accounts top node, inside this node we have sections node, and inside the sections node we have the industry attribute, and the value is banking. So if I just go ahead and execute this, I'll get nothing back. The reason for that is because at the moment this query, it's still looking for this account industry variable, which no longer exists. So the way that how we want to do this is we want to somehow get into this industry attribute, and the way to do that is in JSON you need to go accounts, sections, and we'll separate this by semicolons, and industry. If I go preview again, so now there's no errors, but it's not returning anything. And the reason for that is probably because I haven't got any records that meet this criteria. So what I'll do is I'll just change this to energy and see. There you go. So once I've changed this to energy, I've got records in the Salesforce org that meets this criteria. So when you are doing this exercise, it's important to know if you don't get anything back, have a look at your data. You might need to adjust the filtering criteria or creating new data so that you'll get some response back. A super important thing to note over here is that to access JSON nodes, we need to use the colon symbol, and this is different to the relationship query where it's a dot. So it's quite important to remember this. This will definitely come up in your project implementation, as well as the developer exam for OmniStudio. So that was all the exercises for DataRaptor Turbo Extract. Now let's move into DataRaptor Extract. Alright, first exercise on DataRaptor Extract. In this example here, we'll be using operators to fetch and sort case records using DataRaptor Extract. And we'll be ordering the records by case number in descending order. So it's very similar to the first exercise that we did for DataRaptor Turbo Extract, but in this time around, we will be using DataRaptor Extract to carry out this task. Let's now move into our Salesforce org and create a new DataRaptor. We'll name this DREXT, DataRaptor Extract, case details, and interface type will be extract. Extracting case record details. Right, so the first thing we need to do is let's add extract step over here. We'll be focusing on case. For output paths, we'll keep lowercase, and we'll use cases. And we'll again be getting all the case records. So if you remember back from the previous example, we'll need to fetch all the records with an ID. And to do that, we'll be using not equal to velocity.null environment variable. And in terms of the output, what we'll be doing is we'll be getting the ID And for the output JSON path, we'll keep it a bit different this time. We'll have another JSON node encapsulating the case node. And this is what you can see over here as well, is that in the current JSON output, this is a good place where you can check out the mapping that you are doing. This gives you a good reflection of what the output would look like for your JSON. And before we go any further, it's always good to preview it now, just to make sure it does work before we carry on. So what we've got over here is we've got the records JSON node, and inside this node we have the cases node, and here we have an array, which is shown by the square bracket, and inside the array we have multiple case records. So what we'll do now is we'll continue to add the rest of the fields. So next one is case number, and we'll keep it the same. And the other thing that I like to do is, usually in the output JSON path for DataRaptor extract, I like to keep everything lowercase. This is to distinguish from the actual object field, which is in uppercase. So actually what I'll do is I'll go back to the ID here and change this to lowercase as well. And we'll carry on. Just copy the JSON path here so it's a bit quicker to do. Next one is description, and priority, and as we are adding the map here, you can see this current JSON output gets updated. So this is actually quite important. It actually comes up in the developer exam that it actually asks you what each of these tabs do, and we'll go into this in another video. But for now, let's just complete this. Reason coming up as status, and subject. And let's quickly preview this, making sure all the fields are here, and that looks really good. So now what we need to do next is we need to order the records by case number in descending order. So what we'll do is over here we'll add an operator ordered by case number, and in descending order. So what we can see now is that we have the largest case number up the front, and the further that we go down, the case number gets smaller. So this is exactly what we want. In this example, we will be using formula to manipulate data. One important thing to know is that DataRaptor Turbo Extract does not support formulas. So anything that you need formulas with to manipulate data, you need to use DataRaptor Extract. So in this example, we will be using DataRaptor Extract to fetch all the case records and the following fields. and order the records by case number in descending order. Use the formula function to append case number with priority. So for example, if the case number is 004424, we want to append this with the priority, which in this case is high. Right, let's create a new DataRaptor extract for this. For this one here, we'll name it DREXT case details using formula. Using formula to append case number with priority and save. So what we'll do first is, again, we'll be focusing on the case object for extract output path, or keep it as cases, and we'll be fetching all the case records. So we need to make sure we don't get anything that doesn't have an ID. And we'll quickly put the ID field on as well, and just to check if everything is going okay. So yeah, that looks good to me. So what we'll do next is we'll be using the formula field to concatenate case number with priority. So let's head to the formulas tab. And the reason why this extraction step JSON is here is that this basically stores how the query results will be stored. So at the moment we are storing the query results in this cases JSON node. So this comes in handy when we need to figure out what fields we need to use and what the reference is. So let's add a formula. We'll be concatenating, so we'll be using concat, and this is the same as your Salesforce formula in validation rules or flow. It works quite similar, where the strings are added and separated by commas. So what we'll do first is we will be again using the cases node, and to access attributes inside a node we use the column. And what we're looking for is the case number. Copy paste this, and in between we'll have a hyphen, and will be concatenated with priority. In the formula result path, again, I'll be storing it under this cases node, and we'll call it case number with priority. Oops, we'll copy. What's going on? Cases, case number with priority. We'll keep this lowercase, and we'll put formula in the end, so we know that this is this has been manipulated using this formula here. So in the output, let's go back to the exercise. So we want to append the case number with priority. So what we'll do is in the extract output path, you can see this formula node is already there. So what this is doing is that it's taking the query result that's been stored in the cases node and apply this formula, and it's now stored the manipulated result into this path. And what we are doing here is we are mapping this path against the output JSON path, and that's the path that will be in our response when we run this DataRaptor extract. So we'll just call this case number. So if I go and preview now, we can actually see the case number here with priority. Now we'll be adding the priority and the case number field back. So what I'll actually do is to make it a bit more clear. We'll put formula here, and we'll put the case number here as well. Case number, notice how it's in lowercase, so we know the difference between the actual object and the node. Next up is priority. And last one is description. So if I go in preview, and when we look at this case number formula node, we can see that it is putting the case number together along with the priority. So that's what we want. And the other thing that's important to show is that we can name the attributes whatever we want, but it's good to name it in a way that's easy as a developer to understand where this is coming from. And in fact, at the moment, I haven't got any output JSON node encapsulating all of these. So that's the reason why these are just sitting inside an array with no node in front of it. So if we want to put a node in front of it due to OmniScript requirements, we can. So we can go form, just add form in front of the case number node, case number attribute, and you can see already this is getting updated. So we'll keep everything inside the form JSON node. And if I go preview again, now everything is, all the records are separated by commas, and these records are inside the form JSON node, and the records are encapsulated in an array, which is shown by the square bracket. Alright, next example here, we'll be using relationship notation and single extract step to do this exercise. So we'll be using DataRaptor extract to fetch all case records and the following fields, where the industry field under associated account is electronics. So use relationship notation and single extract step. So what we'll also do in this exercise is that we'll be using multi-step as well, just to compare the difference between a single extract step and multi-step. And you should be able to see a difference in the queries, and single extract step is the preference as it's more efficient and the performance is better. I've gone this into a much more detail in my data extract video, so feel free to check it out if you want to understand more about single extract step and multiple extraction steps. Alright, let's go into the DataRaptor. So what we'll do in this exercise is that we'll start with multiple extraction step first. Multi-extract step. Extracting case records using multiple extract step. Case records and account and contact records. So what we need to do is we'll need to extract case records as well as account and contact records as well. So let's focus on, for the first extraction step, we'll focus on cases, and again we'll be extracting all the case records. And what I'd like to do is just do a quick query and run it to make sure I've set everything up correctly. So that looks fine to me. So what we need to do next is we need to fetch the industry field from the associated account object on the case record, and also the name field on the associated contact object on the case records. So to do this, we need to add extraction step, and we'll start with accounts. For the extract output path, we can name it, we can specify it whatever we want, but we'll keep it inside the cases node, so that to show that the accounts we are fetching is associated with the case. And the ID of the account should match with the account ID field on the case. So the account ID field is essentially the lookup field on the account. And to know how we refer to this field, we can just click on this. And under accounts, we should be able to see an account ID field that's over here. The reason why it's not inside accounts is that this account ID field actually belongs to the case. So we need to go cases, account ID. The reason for that is because in the first query, the query results will be stored under the cases node, and hence the reason why we need to specify the cases node in order to find the account ID field. Next object is contact, and we'll go with case contacts. And same idea here, we need to find the contact ID there we go, and again under the cases node. Now we've completed the extraction steps. What we'll do next is let's go to the output tab and let's get these fields. So we've got ID, we'll need to get the case number, keep it lowercase, and we'll keep it simple. We won't have any JSON node to encapsulate these attributes. Next one is industry. and the name field contact. And actually, let's make it more clear since we don't have a contact node. We'll call it contact name, and for industry, we'll call this account industry. And let's go and have a look at the preview. So now in the response, we can see an array, and we can see these records with ID, case number, the associated contact name, and the account industry. So this is what we called multi-step, multi-extraction step, and the reason for that is because we are putting in 3 extraction steps to be able to get these fields to show up in our response. And you can actually notice here that 3 queries have been run, 1 on each object. So the first one here is on the case object, second one here is on the account, and the third one is on the contact. So this is not a very it's not a very efficient way to do things. What we'll do in the next example is that we'll show how we can use relationship notation and a single extraction step to achieve the same result. What we'll do is we'll keep this tab over here, and we'll create a new DataRaptor, so we can compare side by side. We'll call it the ext single extract step using relationship notation to extract parent record, parent object details. Again, what we'll do first is case object. Again, under cases, ID will be fetching all the records. And as a quick test, we'll get it to display the ID field. So it's working fine. So what we'll do next is that we'll be using relationship notation to extract parent records, and we only need to do this on the upper mapping. So we have ID. What we need to do next is case number. Keeping the output JSON path simple and lowercase to distinguish between the JSON node and the actual object. And what we want to do next is we want to fetch the industry field from the account object. So to be able to fetch fields from parent objects, we need to use relationship notation. So how that works is it goes by parent dot field. So in this case, we need to go with the industry field from the account object. So it'll be account dot industry. And again, notice how to access JSON node it's colon, and for relationship notation it's a dot. And the important thing to know is that for relationship notation, you need to enter that manually. It does not automatically appear under the extract JSON path options. So for output JSON path, we'll go with account industry. And let's see if this works. So yep, so now it's able to get the field from the account. And notice how here we've only run a single query. We'll revisit that in a bit. Let's get the contact name as well. So cases, contact, which is the parent object, and name is the field on the contact. Contact name. Go with preview, and now we are able to fetch the contact name as well. So the important thing to know is that with relationship notation, it's not only quicker to set up, it's more efficient as well. It has less extraction steps and less query. As over here, we can see that it's using the relationship notation, account.industry, contact.name from case. And to compare this with the multi extraction step approach, over here on the case, it doesn't have any relationship notation. Instead, it's fetching the contact ID when the query is on the case, and when the query is based on the account object, it's then fetching the industry field. And it's a similar scenario with the contact as well. It's fetching the account ID and the ID from the contact and the name as well. So this is one of the advantages of using relationship notation. It's easier to set up and it's more efficient. So one thing that we still need to do is that if we come back to this exercise, we need to set up a filter where the industry field on the associated account is equal to electronics. So what we'll do over here is we'll go back to the extract step, and we'll update the filter to be account dot industry. Again, this is following that relationship notation, parent dot field is equal to electronics, and because it's a string, we need a quotation mark. Let's have a look in preview. So now we've managed to find all the case records where the associated account with industry of electronics. In this example, we will be working with complex JSON, just like what we did for DataRaptor Turbo Extract. So what we want to do is we want to modify the DataRaptor we created from challenge number 3 and to take the following input JSON. So challenge number 3 is what we just did, the single extract step using relationship notation. So what we'll do with this exercise is that we'll clone this DataRaptor extract. We'll call a dr extract single extract step complex input JSON. Save. And what we'll do first is we'll need to enter this as the input JSON parameter. So again, starting with open and close curly brackets. Top node is accounts. the next node is sections. The attribute is industry, and the value is banking. We'll just put this into JSON lint just to check if we've missed anything. Validate JSON, and that's all good. Copy, paste it back here for better formatting. So what we need to do next is coming back here, replace this hard-coded value with the JSON path. So starting with accounts, followed by sections, and the attribute we're looking for is industry. So if we run this again, and now we're able to see all the records where the industry is banking. So there was all the DataRaptor extract exercises. Coming up next is DataRaptor load. Before we get into it, if I could ask a small favor to get you to hit the subscribe button if you haven't. This will help me a lot, and it would encourage me to make more great content like this, and also will help get the videos out there to help people learn OmniStudio for free. Thank you so much, and now back to DataRaptor load exercises. Alright, DataRaptor load exercise number 1. In this exercise, we will be inserting multiple records for a single object, and we'll be designing a DataRaptor load that can create these 3 test accounts. Let's head into OmniStudio and create a DataRaptor load. We'll call it the DR load multiple records single object. Interface type would be load. Creating 3 test account records. Click on save. Now that we're in here, we want to be focusing on the accounts object. We'll add an object, we'll name it account. What we'll do next is we'll carry out the field mapping. And we actually know the input JSON over here, so what we'll actually do is we'll go and type this in. It's actually quite a good exercise to try and type in JSON as often as possible. This will get you familiar with the JSON context, and that will help you to prepare for the exam or for actual project implementation. So one of the advantages of typing in the input JSON is that once you have typed in the expected input JSON structure, when you do the mapping, you'll be a lot faster. Here you'll actually be coming up with recommendations for the input JSON path. So let's give this a go. So we want to create 3 test accounts. We always start with open and closed curly brackets. For the node, we'll call it accounts. We can actually call whatever we like, but to follow good practice, it's good to call it something that resembles the object that you are trying to create. Since we'll be creating multiple accounts, we'll need an array, which is shown by the square brackets. Inside the array, we'll be creating 3 key and value pairs. So we'll go with account name, test account 1, and to create another object, we separate it by comma and another open and close bracket. curly bracket. I'll call this test account 2 and 3, and delete the comma. And what we'll do is for formatting and validation, we'll go to JSON lint and just copy paste this here and validate it to see if it's okay. So that's valid. So what that means is that there is no syntax error. We'll copy paste this back. So now if we go back to here, you'll see that the input JSON path is coming up with a suggestion with the accounts node and the name attribute. So what we want to map it to is the name field in the account. So everything that you see over here, you'll be able to find that in the object manager. These are all actual object fields. And we'll go to preview. You'll notice that if I just hit execute now, nothing is being created. That is because we need to have a test input JSON. And if we go and execute now, you'll see that 3 accounts have been created, and we'll just go take a look at the second one. What we are expecting is that the name field should be populated with test account 2, so that's correct. And we'll pick the third one, and what we are expecting is test account 3 under the name. So yep, that's correct. Exercise number 2. In this exercise, we will be inserting multiple parent records with multiple child records. So again, designing a DataRaptor load that can create case records and the associated contact record. So in here, under the case, we have 2 case objects that we will be creating, one with the subject field broken engine and the other one with broken seatbelt. And also with the case object, we also want to create an associated contact with last name Bryant for the first case object and Kobe for the second case object. Alright, let's create another DataRaptor. We'll call it DataRaptor load multiple parent records. Multiple parent child records. We're creating 2 case objects and 2 associated contact objects. And interface type is load. Click on save. Right, what we'll do first is we'll be adding the case object. We'll also be adding the contact object. And what we'll do next is we'll go to JSON lint and start working on our JSON. So we'll always start by open and close curly braces, and we'll start with the cases node. And since we have multiple case records in here, we need an array. First case record, again in curly brackets, and the subject is broken engine. And for the associated contact record, again starting with the double quotation mark with the node contact, and in here we want to go with last name, which is a required field. Bryant. So it looks a bit messy now, but once we validate it, it'll look a lot tidier. And since we have this already, we can duplicate the first case and contact record, copy paste it, and modify the subject to broken seat belt. Last name will be Kobe. Validated, so still valid. Copy paste this back to here, and what we'll do is we'll start the mapping exercise of two things. The first thing is that we need to establish the link between these two objects, and which brings us to the second point, is that when establishing the link, we need to identify which object is the parent object. So if we go and have a look at the object manager, the easiest way to figure out is that we'll pick on one of the objects that's say case. So if I can see a lookup field to the account, to the contact, then this pretty much tells us that case is the child. Usually the lookup field is on the child object, looking up to the parent. So what we need to do is, coming back to our DataRaptor load, we'll need to put the parent first and have the child afterwards, and add the link on the child. So when adding a link, what we are trying to do is we're trying to link the contact name on the case object to this contact record that we are creating. So this contact name field has the API name of contact ID, and we're linking with this number one contact object here, and we are linking it with the ID of this contact record. So now if we go back and just check all the mapping again, you'll notice that it automatically added a contact ID lookup on the case under the case section. And if we go to all, this will show us all the fields. So let's now go and hit the preview button. So what we are expecting now is, if we look at one of these contacts, we should expect to see a case under the related list. And if we see a case record, we should expect to see a contact name being populated. Right, so first thing, we'll start mapping the case record. You'll notice that over here, because we have two objects selected, you also get two tabs. So we'll start with the case object. So this will need to map to the subject field. The other good practice is that for all the input JSON, I've kept it as lowercase. So this will help you in distinguishing this from the actual object field. So a good thing to do is, usually these input JSON will be coming from the OmniScript or integration procedure. So when you are sending JSON from OmniScript or integration procedure, it's good to keep them as lower cases, so that when you are designing your DataRaptor load, you can tell easily between the actual object field and the input JSON. So we've got the subject field here, and we'll do the last name field here as well. So now we should be ready to go. There's actually one thing I haven't done, but I wanted to run this first and explain to you why we need to do it. So if we just go and execute now, we've created 4 records. But if we go into one of the case records, what you'll notice is that there's no the contact record, the contact name here isn't being populated. And the reason for that is because this brings us to exercise number 3. In this exercise, we will be inserting a single object record linked in multiple object hierarchies. So we'll be designing a DataRaptor load that can insert a case record. This case record should be linked to a contact record, which in turn is connected to an account record. And we need to come up with our own test input JSON. Let's create a new DataRaptor load. In this example, we'll call it the load single object multiple object hierarchies. Interface type load, creating a case record and associated contact and account record. So what we need to do first is let's go to JSON lint, and we'll start with creating our own input JSON to create cased account and contact record. So always start with open and close curly brackets, starting with a case record. And because we are only creating a single object record, we don't need the array symbol here. We only just need an open and close curly bracket. Inside the case record, we'll again be populating the subject field, broken engine, comma, and we have the account record. We have a contact record as well. And in this contact record, we will be populating the last name field, Bryant. And inside this contact record, we have an associated account. And inside the account, we'll be populating the account name. We'll call this Bryant account. And let's validate the input JSON so that it's all valid. I'll copy paste this back to here first. Now that we understand what we're aiming for, let's go back to the object here. So we are creating 3 objects: case, contacting, and account. So account is the parent of both contact and case, hence we are putting in this first. This will be followed by the contact object, which will become parent of the case object. So similar to the previous exercise, we need to establish the link here. So on the contact object, the account lookup field, we need to link that with the account record we are creating, and which is identified by the the ID field. For case, we need to link to both the account and the contact record that we are creating here. So a good way to do this, if you are not too familiar with the object itself, is that I would usually go to the record and have a look at what's actually on here. So for the case, you'll notice that there's contact name and account name. So these are the two lookup fields. They are on here, the domain object field. So these are field labels. That's why it looks a bit different from what's being shown here. To really look at the options that are coming up here, we'll need to go to the object manager, and if we look at the account name, we can see the field name is account ID, which is what we are seeing over here, and that's the same case with contact as well. We can see the contact ID here, and it's a lookup field as well. Now let's go to the Fields tab and start the mapping process. So for accounts, we want to map the name field to the name, and for contact, we want to add the last name attribute to last name, and for case, we are populating the subject field. So let's now go to the preview tab, copy the input JSON and make this as our test input. Go execute, and now we can see three records over here. Let's take a look at the case record. What we are expecting is that both the account and contact field should be populated, and if we look at the account, we can see it's related to the Brian contact record and the case that we have just created. So this is more of a complex example. If you are finding trouble following this, I would suggest you to revisit the OmniStudio DataRaptor load video that I did. In that video, I've gone into great detail as to how all of this works, and I've also given real life scenarios, so that should help you to bring you to speed. Alright, exercise number 4, inserting multiple object records linked in multiple object hierarchies. So in this exercise, we will be using the same DataRaptor load from challenge number 3, but we'll be modifying the test input JSON so that we can create multiple case records, multiple account records, and multiple contact records. Right, let's go back to the DataRaptor from exercise number 3. We'll make a clone of this, and we'll name it multiple object hierarchies. Save. So with this exercise here, we actually haven't got to change the design of the DataRaptor. The only thing that needs changing will be modifying the input JSON to allow us to create multiple records. So what we'll do here is we'll copy paste this input JSON onto here, and we'll modify this JSON so we can create multiple case contact and account records. So since we are creating multiple case records, we need to add the open and close square brackets for the array. And once that's done here, we'll need to identify the object, open and close curly bracket, which is this over here. So what we do is to insert another case record, just put a comma here, and we'll just we'll append everything with number 2. We'll make this number 1, and to add another one, we simply just add another comma and paste it. We'll make this number 3. And we'll just copy paste this back to here. So we shouldn't have to change our design because we are only adding the JSON structure, and the text hasn't really changed. We are just adding another 2 objects that we are adding. So let's go to preview and update the input as well. Click on execute. So now we've got 3 case records. Let's take a look at the first one here. Right, I think that became the second one. So, but it's correct. It's got Brian 2 as contact, account 2 as the account. We'll take a look at the second one as well, and this has become the first one. So with the case name broken engine 1, so this should be the third one here. Yep, that's it. Exercise number 5, upserting records using recordId. So in this exercise, we will be designing a DataRaptor load that can update the subject field of the case object record when provided with a recordId. When a recordId is not provided, creating a new case record. And we will again be designing our own test input JSON. So what we are basically doing here is creating a DataRaptor load that's capable of upserting according to whether a recordId has been provided or not. Let's create a new DataRaptor load. We'll call it the load upsert case record. Load description upserting case record based on recordId. So in this example, we will be focusing again on the case object, and we will be updating the subject field. So for the object, again, we'll be selecting case, and we'll start with designing the input JSON first, so we know what our target is. So again, open and close curly brackets. We will have a subject field, and we'll update to case upsert we'll just call it case upsert. And depending on whether we are providing with an ID or not, you'll create or update the record. So for now, we'll just we'll leave that out for now, and we'll just map the subject field here. So if we go ahead and do it now, it should just create a record with the subject written as case upsert. So if we copy this recordId and put it here, remember to put a comma as well. And if we include the ID in here, and by default, ID becomes an Upsert key, regardless of whether you have ticked this or not. So if we go to preview now, and actually let's just change this to Upsert key 2. If we go execute, the ID should stay. Oh, actually, we'll need to remember to include this into our test input JSON. The ID should stay the same. And yet it stayed the same. So if we just refresh this record, we should see a number being appended to the end. So coming back to here, in my video on DataRaptor load, I've gone over all the options here in detail, especially on the Upsert key. So if we tick this now, it actually wouldn't make a difference. So you might ask what this Upsert key is for. It's actually for fields that you want to use as an Upsert criteria, but it's not an ID field. For example, if you have another external ID field, or a field that you want to use as a unique identifier for upserting, then this is where this option becomes useful. Otherwise, if you are just using the ID field, you can, this is optional, but I usually tick it anyway. So it's easier to understand by other developers, knowing that we are using this as an Upsert key. Right, so what happens if we are creating an Upsert DataRaptor, right? So if we remove the ID field, what will happen now is this ID should change. It should now create a brand new record called case Upsert 3, and the ID was different than the ID we had before. Alright, exercise number 6, Upsert records only when Upsert key is provided. So we'll be using the same DataRaptor from the previous exercise, and we'll modify it so that you'll only perform record update if the ID field is provided. Also modify the test input JSON as required. So what we'll do is we'll clone this, and we'll call it the load update case record. So essentially what we are doing is that we are making this ID field required for Upsert. So what this means is that if the ID isn't provided, nothing will be done to this record. So we are essentially turning this record into this DataRaptor load into an update DataRaptor, whereas the previous exercise number 5, you can have two scenarios. You can either create when the ID is not there, or update when the ID is there. So it's more of an Upsert DataRaptor as opposed to this DataRaptor here, which only does updates. So to make this required, we just need to tick this is required for Upsert option. And if we go over here, we had this ID before. I'll just put it in for now. Take a look at this as well. So at the moment, the name of this is case Upsert 2. We'll change it to case Upsert 3. So that's fine. The ID stays, and when we refresh, this should go to Upsert 3, correct? So what happens if we don't provide the ID and we change this to Upsert 4. So in the response, nothing actually gets created. And when we refresh, it stays as Upsert 3. So what this is telling us is that it won't create a record and it won't update if there is no ID field here. And actually, by taking this, you are essentially making this DataRaptor load update DataRaptor, because you have to have the ID provided, and the ID is being used as a Upsert key to update records. Exercise number 7, updating case record fields. In this exercise, we will be designing a DataRaptor load that can update the subject and status field of the case object record, and we will again be designing our own test input JSON. Coming back to here, we'll clone this DataRaptor. We'll call it the update case record fields. We'll save this. So case object is here. In terms of fields, we'll be updating the subject field and also the status field. So what we do is we update this input JSON and include status, and let's have a look at what status values are there. We'll go with closed. So now if I go status and just copy paste this here and just check this is the case record we will be looking at, so we can look at the differences in the before and after. So name this case Upsert 10, update the status to closed, and just add a comma here. It doesn't matter, but previously I was wondering why the status wasn't coming up automatically. It was because I was missing a comma. But that's all good. Now I enter them manually. So if your options are not coming up here, chances are your input JSON might be having the wrong structure. So coming back to the test input JSON, execute. So that the case record stays the same, and if we refresh, the status will be updated to closed and the name updated to case Upsert 10. Exercise number 8. In this exercise, we will be performing a lookup operation on other object fields. So we'll be using the isLookup mapping option on the DataRaptor load to perform a lookup operation on the username field within the user object. So upon lookup, the email field of the user object will be retrieved, and subsequently this email field should be written to the website field of the account record, and we'll again be designing our own text input JSON. Let's create a new DataRaptor load. We'll call this one DRLoad lookup, interface type load, lookup operation on the user name field, user object, retrieve the email field data and write it to the website field of the account record. Alright, so the first thing we need to do is let's take a look at the exercise. So we'll essentially be creating an account record with the website field obtained from this lookup operation. So we'll be adding the account object, and the next thing to do is I'll usually work on the input JSON so we know what our end goal is. So we'll be providing the user name field, and actually before this, let's just open up a user record. So what we are doing is essentially this username field over here. We will be providing this, and so let's come back here. Just keep it as this username. So in our input JSON, we'll be providing the username field, and this DataRaptor here will be using this username field as a input to the lookup, and basically using this, if there's a match, it uses this to return the email address. And also to create an account, we always need an account name, which is a required field. Cloud with Ryan. So now let's start the mapping process. So we'll start with the account name, and next one is the username. So the username field will go through the lookup operation here, and you'll end it up on the website field of the account record. So what will happen is that the username field will be used in the lookup operation, and we'll find a match on the username field and return the email field of the user object. And once we have this email field, we're going to write it to the website field of the account record. So the domain object field will be the website. So that's basically the final field that we're going to write it to. So the result of this lookup will be written to this website field. So because we are going with the lookup operation, we need to tick this lookup checkbox. And the lookup object is the user object. And the lookup field is the username field over here. And the username will basically be getting the input from this username attribute. And we wanted to return the email field. Right, so we'll copy paste this and put it in our preview. And again, this is quite an advanced operation. I've also covered this in the DataRaptor load video. So if you want to understand more about how all of this works in the background, feel free to check the video out. So let's execute this. So it's now created an account object. So what we are expecting with this account object is it should have a name cloud with Ryan, and the website field should be my email field. Yeah, that's it. So if we were to, for example, create, we'll check this user here. We have this username right here. We'll update the test input username with this, and we should come back with this email address on the new account. So we'll go execute. Another account has been created, and the email address is no reply at example.com, which matches this. So this is a bit like the XLOOKUP on Excel. Great work, guys, for making this far. Next up, we have data transform exercises. Alright, DataRaptor transform exercise number 1. Convert a single item into a list with one item. So in this exercise, we will be designing a DataRaptor transform that takes the input JSON on the left and transform it to output JSON on the right. So basically, we are converting a single item here into a list with one item. Let's create a new DataRaptor transform. We'll call it the TX. Single item to a list with one item. Interface type transform, converting a single item into a list with one item. Save. Alright, so what we want to do here is let's put in our input JSON. So again, open and close curly brackets, and we have this context node. Inside this context node, we have a first name attribute. The value for this key is Tom. And we want to convert this into a list with one item. So let's start the mapping process. So what we want to do here is, again, we want to put whatever is in here into a list. So in our JSON input path, we are not actually interested in specific attributes. Instead, we are only interested in the node. And what we want to do is we want to convert this into, want to transform this into another node. And within this node, we have a key and value pair, which is basically a map. So in the output data type, we need to go with list map. And if we have a look into the current JSON output, we can see the contact list node, also an array, and within the array we have the item over here. And if we go and preview, we can see the contact list node with an array and a single item in here, and that is matching with what we have for this exercise. Exercise number 2, converting a list of objects into a list of values. In this exercise, we will be designing a DataRaptor transform that takes the input on the left and transform it into the output on the right. So essentially, we are converting a list of objects, in this case 2 contact objects, into a list of values. Alright, let's create a new DataRaptor load. We'll call this the DataRaptor transform. We'll call this list of objects to list of values. Interface type transform, converting a list of contact objects into a list of email values. Again, first thing first, we'll work on our input JSON. We'll be having a context node. Inside the context node, we have it's an array with 2 objects. Inside this object, there's the first name attribute with same being the value, last name, Thomas, and email, same at gmail.com. Now that we have this, we copy paste this object and make it, modify it for the second object, and we'll just copy paste this to JSON length just in case if we've made any syntax mistakes. So that looks good. So what we need to do in this example is that we need to extract the email attribute from the contact node for all the objects. So to do this, we're going to have to use a formula field. Sorry, not formula field. We're going to use the formula function. So let's come back to here and go into the formulas tab, add formula. And what we need to look at is we're looking at this context node, and we need to basically get the email attribute. And we'll save this into context email. We'll append this with a formula in the end so we know that it's a formula. So what this will do is we have the input JSON coming in, and this will basically go into the formulas to be manipulated, and will be for each context. Inside the context node, we'll be extracting the formula, the email attribute, and store into this JSON path context email formula. And in the transformation, we'll feed this node into, let's have a look at the exercise. We'll feed this node into the contact email address node, and we'll go preview, and there you go. So this gives us the contact email address node with an array, and within the array we have the email addresses from the context, and that's what we have here. And it's got look here, but we haven't got look in the context, so that's why it's missing. We can actually add look here as well. We'll copy this, execute. There we go, look has been added. Exercise number 3, converting a list of objects into a multi-select item. So in here we'll be designing a DataRaptor transform that takes the contact node with 2 objects in here, and we want to convert the first name of each object into a multi-select item. So what we'll do here is we'll copy the test input JSON from the previous exercise. and we'll create a new DataRaptor transform, and we'll name this the tx list of objects to multi-select interface type transform convert a list of contact objects into a multi-select item of names. First thing, we'll copy paste the input JSON from the previous exercise, and again, similar to the first exercise, we need to get the first name field from all the objects. So we need to again utilize the formulas to do some manipulation. So let's go to the formulas tab, and we'll add the formula. And what we'll do is we'll go in the context node, and first name, we want to store this into a new formula result path node, adding formula to the end so we know this is coming from the formula. In the transform, we'll take the manipulated result into this new node, contact name select, and for the output data type, we need to select multi-select. And let's have a look into preview. So now what we've got here is a contact name select node with the name options in a multi-pick list format, multi-select format, sorry. And I just realized I probably made a typo here, since this is a multi-select pick list. It shouldn't be in an array, so it should really look like this. So it'll just be open close square bracket with the node contact name select, and inside this node we have the first name of each object. Alright, exercise number 4, converting yes or no string to Boolean values. So in this exercise, we will be designing a DataRaptor transform that takes this input JSON with yes or no string values into Boolean values, true or false. So over here on the left, we have a contact node, and it's an array with 2 objects. Inside the object, there is the active attribute with a string yes value, and the other object has a string no value, and we want to convert it to the same key, but a different data type to Boolean. So let's create a new DataRaptor transform. The tx string to Boolean, converting yes or no string values into true, false Boolean values, and interface type as transform. Right, the first thing we need to do is to copy paste the input JSON from the previous exercise. and we'll modify it so it meets with the detail, it matches with the details of exercise number 4. So we keep the first name and last name. We'll replace the email key value pair with active, yes, and active, no. And we'll just double check active yes, active no. And what we want to do is to speed this up a bit, we'll also copy paste the expected output JSON. So copy paste this one and put it over here. And so everything is the same apart from this. Right, with this being done, now let's start the mapping process. So we basically want to map it, map the first name first. So there's, apart from the active attribute, the rest will be a one-to-one mapping. So last name will just go to the context last name node, and the active one will go to the active node as well. But the difference is that because we want to convert from string into Boolean, the output data type needs to be specified. And also we need to add key value pair as well. So if the input is, just change this to uppercase as well. If the input is yes, we want to consider this as true. And if the input is no, we consider this as false. So let's run this. So as we can see here, first name, last name stays the same, and with the active value, it's now being converted to Boolean. So where it's string yes, it goes into Boolean true, string no goes into Boolean false. Coming up next, exercise number 5, transform a single object data into multiple objects. So in this exercise, we will be designing a DataRaptor transform that takes this over here and separate it into different objects with the respective fields. So in here we have first name, last name, email, company, website, username. The first name field and the last name field, and also the email address will go into the contact node. The name from the account will come from the company. The website will come from the website over here. And in terms of the user, you'll be getting the first name, last name, email, and the username. So we'll create a new DataRaptor transform. We'll call it DRTX single object to multiple objects. Interface type is transform, converting a single object into contact, account, and user object. Again, the first thing we need to do is to work on the input JSON. So we'll start with form input node. Inside this node, we have the first name attribute. Value is same, followed by last name. Value is right. Email, sam@gmail.com. company, parts limited, website, partslimited.com, and username sam@lakers.com.prod. Right, we'll just go over here and validate the JSON. That looks good. We'll just paste it back here. We'll also put the expected JSON output out as well to speed the mapping, because at the moment we've got recommendations for the input JSON, but output JSON we still need to put it in ourselves. So let's put the expected JSON in here. So we starting with the contact node. In the contact node we have first name, last name, and email address. In the account node we have company and website, and we'll just change the company node, company attribute to name. And we also have user node. We have first name, last name, email, and also username. And we'll put this in JSON, JSON length, and that looks good. We'll paste it back here. And now what we'll do first is we'll map the first name into the contact first name, and last name into contact last name, and also email as well. Email mapping to contact email. So now we are done with contact, moving to account. So account, we want to map the company name, which the company attribute into the name attribute of the account node, and the website. Moving to the user node, first name to first name, last name to last name, email to email, and username to username. Right, now let's go to the preview tab and execute. So now we've successfully converted the form input node into 3 JSON nodes: account, user, and contact. And within each of these, it's now containing the relevant attributes. So as you can see, it's matching with what we have over here. Exercise number 6. transform a list of items to single objects. So in this exercise, we will be designing a DataRaptor transform that takes what we have here. So a JSON node with an array, and within the array there are 3 values. And we want to convert this into a JSON node and a list of key and value pairs. So for the value same, we want to move that into we want to associate that with the first name attribute. The Thomas, we want to associate this with the last name, and sam@gmail.com, we want to associate that with the email attribute. Let's create a new DataRaptor. We'll call it trdx list of items to single objects. Interface type is transform, transforming a list of items to single objects. Save. Again, first thing we will do is we put the input JSON in here. We have this fields node, and inside this fields array we have 3 values: Sam, Thomas, and sam@gmail.com. So how do we actually convert from this into this? We'll need to use the formula again to manipulate the data. So what we need to do is we need to basically put this field and store it into a node. So we store this into another key. So we'll be converting a value into a key value pair. And to do this, what we'll do is we'll be accessing these elements. So let's go to the formulas tab, and what we'll do is we'll access the first value Sam first. So in DataRaptor, the indexing starts from 1, not 0, so it's quite important to know. And for the formula result path, we'll just put in first name formula, and we'll do this with the second as well, and that will be the last name. And the third value, we'll put this against the email node. In the transform tab, this is where we will turn this into that. And actually, it's probably a good idea that we put in the expected JSON output. So our expected JSON output is, we'll start with the contact node, and inside the contact node we have the first name attribute, value is same, last name attribute, Thomas, and the email attribute, which is sam@gmail.com. Check this against JSON learn, so that looks good to me. Paste it back here. Now what we'll be doing here is we'll be mapping the formula result path. So think about these as variables with the expected JSON output. So with the first name formula result, we'll be matching this with the contact first name, and we'll do this with last name as well, and also the email. So what we can see in the current JSON output is what we're expecting. So now we have a contact JSON node, and in here we have the 3 key and value pairs. So if we go and preview now, and that's what we are expecting. We are converting a list of items into a single object with 3 key and value pairs. Alright, exercise number 7. Transform the object to a list of items using static index. So in this exercise, we'll be designing a DataRaptor transform that takes an object to a list of items. This is basically the reverse of exercise number 6. Let's create a new DataRaptor. We'll call it DRTX object to list. Transform the object to list of items using static index. First step here is to work on the input JSON, and we have a contact node. In this node we have 3 key value pairs: first name, same, last name, Thomas, and email, sam@gmail.com. We'll check this with JSON lint. That looks all good. Come back here, paste it again. So what we want to do next is to basically do the opposite of what we did for exercise number 6. We want to be converting these key and value pairs into a list of items. So only keeping the value part, Sam, Thomas, and sam@gmail.com. So to do this, we'll start our mapping exercise. So starting with first name, we want to map it to, let's just bring up this again. We want to map it into the fields node, and it'll be the first value of the fields node. For last name, it'll again be the fields node, it'll be the second value, and for email, it'll be the fields node again, the third index. So if we go and preview this now, and what we are getting is exactly what we are expecting. We are getting a list of items. So Sam, Thomas, and the email address. Sam, Thomas, and the email address. Exercise number 8. Transform the JSON input as XML output. So in this exercise, we will be designing a DataRaptor transform that takes the input JSON and transfer it to output XML. So we'll be basically taking this JSON format into XML format. So let's create a new DataRaptor transform. We'll call this one here DR tx JSON to XML. And the interface type here will be transform. Input type will keep as JSON. Output type will be XML. Transforming JSON to XML format. Save. So first thing that you'll notice here is that we are start seeing an XML output and current XML output over here. So first thing that we need to do again is we'll establish our input JSON contact node. Inside contact node, we have first name, same, last name, Thomas, and email, sam@gmail.com. Right. And let's start the mapping exercise. So go to context first name for XML. We'll do the same here. Last name, we'll do the same here. And email, do the same here as well. And we'll check out the current XML output. So we basically have this contact tag, and inside the contact tag, we've got the 3 tags. They are matching with our 3 key value pairs. And when we go execute, this is what we are expecting. And that's it, folks. Good work for completing all these exercises and scenarios. I'm quite confident that if you've completed this video, you should be able to tackle most of the DataRaptor scenarios you'll ever come across, and you'll be able to do very well in both the consultant and developer cert on the DataRaptor section. So if you enjoyed today's video, please subscribe and share this with your colleagues and friends to help us to get the video out there for people that want to learn OmniStudio for free. In the upcoming weeks, I'll be creating a series on FlexCards. Again, I'll be going into very deep details, so stay tuned. We'll see you in the next video.